Networks, whether wired or wireless, rely on an array of hardware components to function effectively. At the core of any network is a router, which directs data traffic between devices and, in many cases, connects the network to the internet. Switches are another critical component used in wired networks to manage and distribute data between connected devices efficiently. For wired connections, Ethernet cables provide the physical links between devices and the network infrastructure, offering high-speed and reliable data transmission. Servers, which store and manage shared resources such as files, applications, or databases, are often essential in larger networks. Additionally, network interface cards, NICs, are required for each device to enable them to connect to the network, whether through wired or wireless means. Wireless networks, on the other hand, require wireless access points which transmit and receive data signals to allow devices to connect without physical cables. For a network to function seamlessly, all these components must be properly configured and maintained, which can involve significant investment in hardware and expertise. Wireless networks have transformed the way we connect to the internet and communicate, offering numerous advantages and some notable drawbacks. One of the primary benefits of wireless networks is convenience. Without the need for physical cables, devices can connect from virtually anywhere within the network's range, making them ideal for homes, offices, and public spaces. This flexibility enables users to move freely while remaining connected, which is especially valuable in environments where mobility is essential, such as warehouses or hospitals. Wireless networks also simplify installation, as they eliminate the need for extensive cabling, reducing setup time and costs in many cases. However, wireless networks are not without challenges. One of the most significant drawbacks is their susceptibility to interference, which can degrade performance. Factors such as physical obstructions, other electronic devices, and competing wireless signals can disrupt the network's reliability and reduce connection speeds. Additionally, wireless networks generally have lower speeds compared to their wired counterparts, especially in environments with many users or devices. Security is another concern, as wireless signals can be intercepted more easily than data transmitted over physical cables. While encryption technologies like WPA3 have improved wireless network security, improperly configured networks remain vulnerable to unauthorized access or data breaches. Moreover, the range of a wireless network is limited, and extending it often requires additional hardware, such as repeaters or mesh systems, which can increase costs. In contrast, wired networks, while less flexible, provide more stable and secure connections. The physical connection offered by Ethernet cables ensures minimal interference and high-speed data transfer, making wired networks suitable for tasks that demand consistent performance, such as online gaming or large file transfers. However, the need for extensive cabling can make wired networks cumbersome, particularly in environments where devices are frequently moved or rearranged. In conclusion, networks, whether wired or wireless, depend on a variety of hardware to operate effectively. Wireless networks offer the significant advantage of mobility and ease of installation, but they face challenges related to interference, security, and speed. Meanwhile, wired networks provide superior performance and reliability, but lack the flexibility that wireless solutions offer. The choice between wired and wireless networking often depends on the specific requirements of the environment and the balance between convenience and performance.